Hello, everyone. Thank you for being here. Welcome. Welcome. Just a quick note, housekeeping items. Please sign in on the sheet on the homemade pallet table. There are still some snacks and coffee, so help yourself to that. Do not forget to sign in, please. We really want to know who's coming to these things, who's interested. It helps us a lot. My name is Yannicka Schopp. I'm with Passivhaus Minnesota. Passivhaus Minnesota organized this tour in collaboration with our project partners. Passivhaus Minnesota is the local North American Passivhaus Network affiliate. It's basically a fancy way of saying that we're all really excited about Passivhaus, and it's a group of people that get together and talk about that. Passivhaus Minnesota is an organization that meets monthly, and it's an open meeting. So if you're interested in joining, you can come to these meetings, see what's going on locally with Passivhaus. We use the International Passivhaus Standard, which is the North American Passivhaus Network tie-in. And that's an important distinction that we can talk about later if you have questions on that. But thanks very much for coming. And so the other housekeeping piece I have about Passivhaus Minnesota, Passivhaus Minnesota is a membership organization. We're volunteer run. We're taking donations at the door, as you may have noticed, so any donation helps a lot. We appreciate if you're able to donate today. And membership with Passivhaus Minnesota is listed, the costs and the benefits are listed on our website if you want to check us out. We have cards at the front. We'd really appreciate it if you're excited about this concept and want to push it forward. Become a member, encourage your friends to become members. We put on these tours, we get together a couple of times a year in different capacities, so we'd really like to see your face there. So. Remember to sign in, don't forget that. So this tour is organized by Passivhaus Minnesota and our project partners. Project partners include Reuter Walton Construction, who is putting this building up, rising it from the earth. The project was designed by TE Studio. This is Tim Ayan, the principal at TE Studio. Lots of people here to answer your questions if you have them, both about the building and about Passivhaus. Safety items. Can someone from Reuter Walton please step forward and talk about safety items?
They're all helping with safety. A couple of pieces. Please don't play with the windows. We'll show you the windows today. They were just installed. We don't want people to help themselves to try to open, close, move stuff. Don't wander off. It's a live construction site. We want you to be safe and leave here with all limbs intact. So listen, look around you, make sure that you stay safe that way, and try to stay together here as we guide you through the building. There's some openings up above, be spatially aware of what's around you. Don't trip, don't fall, and please don't wander on the site. It's gonna be slippery and muddy out there today. We want you to be safe and enjoy yourself and learn something. Did I forget something, Josh? Josh is the site supervisor here for safety.
And everything else. I think you covered most of it.
Okay.
Yeah, just be very cautious. There's just some small ones around, so watch them. There's plenty of open holes, plates on the floors. Watch the heater, that's right at forehead height. And windows and doors, I guess if you'd like help, please ask somebody from either T Studio, myself, or Tim, or he is. We can help you operate the windows and doors. And I think that's primarily it. So enjoy yourselves, ask a lot of questions.
So I'm going to kick it off to Tim Ayan of TE Studio. He's going to talk a little bit about what Passivhaus is and answer, we'll have a Q&A at the end of the session.
Yeah, we'll do that at the end today. I just want to give everybody an opportunity to learn the whole story of this first before we engage. Often there are deep questions and we'd love to talk about them, but we'll probably do that at the end so that everybody gets a basic intro, and then those who are interested can stay behind. We'll probably stay down here for the most part, but you're welcome to explore the other parts of the house. I'll give you a little bit of the background of the Passivhaus Building Energy Standard. It's actually something that originated sort of in the Midwest here. For those of you who remember the first oil crisis in the 70s, that was sort of a starting point for people to think about energy efficiency in buildings a little bit harder. It was also a period of time when people had a deep environmental concern. And so out of that period came a concept called passive solar. And what that meant was making large south-facing windows to invite the sun in, particularly in the Midwest and colder climates, and start to heat a building with that. Now, in those decades, in the 70s and 80s, that approach was hindered a little bit by the technology. The windows just weren't very good in those days. And so what they did back then is they relied on heavy thermal mass on the interior of the building to load it up with sun energy. And then the hope was that it would radiate that back out overnight. And those buildings would have quite a bit of temperature swing between day and night, which is not great and awesome for comfort. And so since then, this approach has been fine-tuned and eventually turned into a building energy standard that was pioneered by a Swede and a German professor in the late 80s, early 90s, and then became a global system that was rolled out and made available to architects such as our firm to bring to projects. And there are 5 principles in the Passivhaus standard that make this thing tick. The first one I already talked about is the Passivhaus Window. In our cold climate zone, what that means is it's a glazing unit that is well insulated, but also has a high solar heat gain coefficient. So these windows here insulate at center glass at about an R value of 11, so about as well as a 2x4 wall. And then at the same time, they have a solar heat gain coefficient of about 53%. So about half of the solar energy that hits it is allowed into the space. And what that does in a building like this is it provides about 2/3 of the heat load on a cold winter day for the entire building. So what you're looking at here is effectively the heater. That's a core component of Passivhaus. The frames are also insulated. And in this case, you can see they have some girth to them, which is pretty typical. They'll be tilt and turn windows, and I can demonstrate later how they operate. And in this building, what's unique to this design, we also have 2 lift and slide doors. So doors that essentially lift out of their gaskets and you can push them open and close. So we'll talk about that some more today. So the other 4 components, let's run through them in order. Super insulated building envelope. Super insulation generally in our area means about 2 to 3 times as much insulation as a code-built building would receive. Our R values in the walls will be in the 50s. Our roof will be in the 70, 80 range, and anything that's below grade will be in the R30 to 40 range. And so the entire building will be wrapped in what's essentially a winter coat. It's not that cold outside, but living in Minnesota, I'm sure you all know what it's like on a really cold day. So this building wears its winter coat all year round. And that's good in the winter and in the summer because it also helps to keep the cold in the summer. We're really not concerned with cooling as much in Minnesota because we have a very small cooling load compared to our heating load. The next piece of that puzzle is air tightness. You also want to build airtight simply because little imperfections in the building envelope allow air to filter in, filter out, and that's not good for energy performance. We're very close to having the air tightness layers finished on this building. When you look at it from the outside, you can see that reddish board that is all taped up. That's our air barrier on the walls. There's bits and pieces of blue membrane poking out around the perimeter. That's the air tightness layer in the floor. There'll be a membrane above me in this roof here, which has a rooftop terrace on top of it, and then more of that on the floor above us. So those components are starting to come in. Upstairs, if you look very carefully, you can see where the walls connect to the ceiling. There's a little bit of a sheathing material hanging through there, and that will later be taped to a membrane that covers the whole surface. That's our air tightness. Air tightness is also an insurance policy for the longevity of a building. In Minnesota, with the harsh temperature differences, if you're leaking warm, wet air into the building envelope on a cold day, it can condense out, become water, and then later produce problems. So air tightness is an insurance policy for a long-lasting building. That's the second, or another piece, the third piece of the puzzle. Then we have one that is maybe less meaningful to the general public, more to practitioners, the avoidance of thermal bridges. The best example I can make for you for what is a thermal bridge is if you have any members of the building that traverse from the inside to the outside. This building will, in its final state, have canopy roofs, both on the south side and on the entry connecting to the garage. And those roofs are very carefully crafted so that they don't connect to the interior of the building. And that's a key component because any connection we have inside to outside is a superhighway for energy to essentially escape the building. So we need to avoid that. That's mostly a design exercise. And then the last piece of the puzzle is heat recovery ventilation. Any building should have a ventilation strategy, whether that's opening the windows or having a machine, a piece of equipment that brings in fresh air all day round. In this particular case here, that's what we're doing. There will be a machine installed called a heat recovery ventilator. And with the virtue of that machine, we bring in fresh air all day long, 365 days a year. And this incoming air is going to be pre-warmed or preconditioned by the outgoing air. So think of it like a radiator or sort of a cross-counterflow membrane device where every time you expel the stale air from the building, you warm up that core of the machine, and the incoming air is thereby pre-warmed. And in the summer, you can reverse that concept to keep the cold and the dry on the inside. That equipment isn't here yet. We may do another tour where we focus on the mechanics of it. So those, in sum, are the 5 concepts. The other piece that I want to offer up here is a little bit of the story of this project. So many of you arrived over there, so you've already found the first quirk about the site. It has a Lexington Parkway street address, but really you enter it from Mary Lane. It was a little bit unique. It's a pie wedge-shaped piece of property with a pretty good drop-off. So just siting a building on here wasn't the easiest thing to do, and ultimately forced us also to put the garage out front, which we generally try to avoid to not give the car too much presence. But needless to say, here we didn't have a choice. That's the only access we have. This replaces a building that I believe was from the 40s or 50s that was torn down here, I want to say in 2012. So it was a vacant site, and now it's being developed. We worked on this design with the clients for a couple of years or so before it went into production. We're essentially establishing a plateau up here, as you can see. So this is all level ground. The entire site is going to be accessible. That was by client desire. So you can essentially come in on level ground when you come in from Mary Lane. There won't be any steps at the doors or from the garage into the house. So everything will be accessible. And in that vein, there's also an elevator that will ride up in the eye of the stair over there. You can sort of see that room framed. So it'll be accessible to the second floor as well. And part of that story is also the fact that we don't have a basement. It was really about accessibility and level floor living, and also making the most of what this property had to offer. And I'm not standing here by accident. I wanted you to enjoy that. This became obvious immediately, a unique opportunity, a view like this. In the design, that's reflected obviously by virtue of having the glass wall here and really opening it up to get this year round. You can see the Como Conservatory right over there, among other things. So that became, I think, a core part of the design. With that, you can see we're almost at winter solstice. So this is about as low as the sun's going to be, and it penetrates the space almost end to end. So that's our heater for the building. There will also be a mechanism to control this. We're going to install exterior motorized blinds, similar to what you all know as a mini blind, but mounted to the outside of the building. And those can be geared to capture, as much or as little sun and daylight as you want. And that does 2 things. One, it controls glare and light, and the other thing is it controls the heat that is able to come into the space. So there is a point at which the clients may decide it's enough for today, it's warm and cozy, we don't need any more sun to warm up our space, and they can ride the shades down, and they can actually be articulated like any mini blind can, so you can do it in a way where you still get daylight, but you capture some of the direct rays into the space. So that, again, may be something we can show to you at a later date, and certainly in the finished product. Floor plan layout, I want to give you that as well. Right now it's an open space. Most of this will remain open where we're standing here. We'll have a living and dining room area. If you kind of divide it visually by these columns in the middle, these first 2 bays here will be the living and dining room. And then the last bay is going to be the kitchen. And the kitchen will be walled in, but it will have large openings on this side and a smaller opening to the entry with a pass-through. So there'll be an opportunity to reach through, also interact with people from the great room here in the kitchen if you want. And if you don't want it, those openings can be closed off with a shade device so that the kitchen becomes more private. We do have 1 bedroom suite down here that's going to go in the corner. This will double as sort of a soft seating space, a reading room, and it'll offer up the opportunity, if the clients should ever need it, of having a caretaker or somebody move in here and live with them. Right in the center, the small window over is going to be the bathroom, powder bath with a shower on this floor. And then the last small window where the heating device is hanging right now over to the wall is a mud and project space. So our clients are crafty. They want a place where they can do projects. That'll be the project room and also the entry from the garage. We'll have, through that door, a covered walk over to the garage. Again, all level ground. So when you're coming in by car, you can get out of your car under a covered roof and enter through that door over there. The area underneath the stair is going to get fortified to become a shelter space, should that ever be necessary with weather conditions. So we have sort of a last refuge under the stair. And the area that has the table with the goodies on top of it there will be the mechanical closet. One of the benefits of making a passive house is that you have very small mechanical equipment and not a lot of it. So what we have will live in that closet. And I already talked about the elevator that goes into the box beyond. And then we have the stair going up. I'll talk about the upstairs from down here just because it's easier up there. There's walls built. You can see that on your own time. But I'll describe to you what happens when you come up the stairs. There is a gathering space that we call the Commons. If you look east upstairs, there's a big square window. So there's sort of a window seat opportunity for a couple chairs and a space to mingle. Over above the kitchen, we have two bedroom-sized spaces that are going to be used as offices for our clients. And then the rest of it, basically all this space over here is the master suite. There's a walk-in closet, a dedicated laundry room up there, a master bath, and then the bedroom itself. And those are all essentially contained in one suite over on this northwest side. The area right above me that has a slightly different framing pattern here is a walkout terrace. And we do ask that you don't try to get out there today because it's just a roofing membrane. We don't want that to be damaged, obviously. So that's essentially the layout of the space. On the exterior, we will have a patio right outside of this lift and slide door right here that is also going to receive an exterior roof, so you're a little sheltered from the sun and the weather. And the rest of it is just going to get landscaped around here, and that's something the clients will grow into over time. I didn't introduce our clients, and I can finally see them in the crowd. So we have Dave and Diane between the second and third column over there. So if you want to learn more about their motivation and everything else, please find them and ask them questions. There's also from Passivhaus Minnesota a couple of other Passive House owners in the audience. So if you can spot them and find them, they can talk about the Passive House lifestyle, as can Tim over here, who also lives in a Passive House structure in St. Paul. So there's quite a few people here who can speak intelligently about the approach. All right, so with that, I think you have sort of a basic understanding. I do want to talk about maybe the lift and slide door and that window over there a little bit more. So I'm just going to walk over there and show you how they work. I'll open this just a little bit. You'll be fine. So this, you're all probably familiar with the sliding doors that you've seen that are, the standard fare that you get in Minnesota, and they're all notorious for being leaky, and sometimes they don't move very well. This is a very nice product. If you look very carefully, when I flip this here, what happens is the entire door lifts up, and it actually lifts out of the gasket. So it's air sealed when it sits down, and it gets lifted out of those gaskets when I pull the lever here. And as I start to push it, I could do this with my pinky. This panel weighs, from the manufacturer, I think they said that it's about 800 pounds. And I can move that with my pinky. So that's what a high performance, high quality lift and slide mechanism looks like and feels like. Also noise, cars, and so once we close this up, and remember there's no insulation on the building. Car's gone. So Paul Brazelton, who's here, who lives near the airport, we did similar things at his house there. It's actually quite stunning. We've, during the tour, done this with airplanes coming in, and then the airplanes go away. So the point I'd like to make there is that a unit like this, beyond energy efficiency and everything else, it provides a tremendous noise advantage. And I think a lot of our houses are very noisy inherently. This gives you a very quiet environment. So that's the lift and slide. And then I'll show you a tilt and turn window here. So these units here are our standard operator sash, and they have a lever as well. What happens here is when you bring it into the horizontal position, this thing essentially becomes a door right there. So you can just open and close it. And quite honestly, this is going to get used not very often, in my opinion. This is more for cleaning, or if you have really strong odor and you really want to evacuate that quickly. More often what you're going to do is you're going to put it in the tilt position. Handle goes up, you gently pull on it, and the window comes in. And so again, additional benefits to this being a high performance unit, you can obviously see that now. You can ventilate whenever you want. You're not dependent on the weather on the exterior. You're not hanging the finished window into the weather outside. So this is a unique setup with these tilt and turn windows. And then when you're done with that, you can just close it, and there you have it.
Is there a screen?
Yes, there is a bug screen, not installed obviously today, and that'll go in here just like it would on a double hung window perhaps. So essentially there's a couple of pilot holes here generally. There's also a clip-on version, and so the screen sits right here in this outer shell. So it's just the same as you would have in any other window. Any other questions there about the windows? Yeah, please.
What's the frame material of the windows? Of wood?
Yeah, it's a wood window. I believe we have a cutoff over here. I'll grab that real quick and hold it up for everybody to see what it's made from. I'll go back to my favorite corner. There. All right, so hopefully you can see that. Here's a section cut right there, same on this side. So it's a wood frame. It's got an exterior aluminum shell. This is just for durability because that lasts longer than a painted finish, obviously. They also knock a corner out of this thing and insert some insulation. And so what that does is it just ups the performance of the entire unit. And when they're installed in our high performance walls, we actually over insulate these from the exterior. So the building insulation wraps over the window, and the window is actually recessed into the wall closer to the interior than the exterior in this case, but it's sort of somewhere midway in the wall, and what that does is it takes it out of the weather plane. So this window is not right out there at the edge of the building where every bit of wind and snow and stuff beats away at it. It's in a much more protected place. Interior, as you can see, is wood. It's a painted finish. And these come pre-painted. So in this particular case, this is the final product. So we have to handle them with care once they're in. Also, there is an exterior aluminum sill pan to get over the thickness of the wall and channel any water away from the building. These pieces that sit up there on the rack, those are some of those flashing pieces. I think there might be a sill up there at one of them. And so that's kind of what you can anticipate there. Maybe one other specialty for this building, the owner opted to order bird-safe glass because it's pretty exposed and we do care about all things living. So these 6 units around the corner here, these are a bird-safe glass. To our human eyes, we can't really see that, but there is a coating installed which is actually sort of a cross-hatched pattern. If you can see it, it looks a little bit like a bunch of branches twisting around, and the birds can see that. And so this will be a deterrent for them. And that's certainly very unique. That glass is more or less readily available, but doing it in a setting like this on a high performance building is a very unique setup. I don't know of too many projects where that gets done. Maybe a couple other things. For those of you interested in window technology, you can see it's a triple pane window. For Minnesota, that's the most appropriate thing to do. I would strongly encourage anybody to forget about the existence of double pane windows. They're not suited for our climate. And you have a cavity between the various panes that is filled with argon gas. So that's very common and typical technology. There are also coatings on the various sides of this glazing. And these coatings, again, are formulated to allow the sun's energy in, but also to keep the cold out and lock the heat in. So it's made for the application. And maybe one other thing, we're getting real geeky here now, but this thing called the spacer in between the glass panes is also specifically formulated to stop transfer of energy or heat and cold from one pane to the next. And that's actually a very unique component of this brand or this manufacturer. And these spacers, we haven't been able to find those in a United States product. I guess I didn't mention these are made in Germany, these windows. And for the last 12 years or so, we've used these types of windows in all of our projects. And that's in part because in the United States, we don't have access to the same glazing technology and in particular these spacers. And also at the moment, nobody makes these frames here. So
What's the manufacturer's name?
it's Tanner Windows. Yeah, it says that. And there's some stuff from them. And I don't know, Seth might be here. Is he? There he is. So Seth Tanner, just raise your hand. His dad co-owns this company. And then Seth is also the window installer. So if you want to go deep on the technology of the window and how these are put in, he's your guy. One thing to note, because we can still see that, I think, a little bit. If you look very carefully, you can see these circles here, right? So the way that these windows find their way into a building like this is by virtue of large suction cups. So given that they're girthy, that front loader was used with an attachment with suction cups on it, and they came off of a container and they were essentially moved over here. And then these larger units actually come in two parts where the frame is set first and the glass comes in second, and we're still missing the glass stop, which is hanging on the wall. So the decorative trim piece here is not on. And they're not sealed up yet, and that's why there's a little bit of sweating there. And also the concrete that you're standing on wasn't here a couple days ago. So we're standing on wet concrete. We have no insulation. It's freezing cold outside, and thing is still drafty. So from all angles, onslaught of Mother Nature. All right. Maybe mechanical systems real quick too for the building, just so that you get the full picture of how is this thing going to run and operate. I already talked about ventilation machines, so we will have that. It'll be mounted on the second floor in the laundry room. That thing looks about like a mini fridge. I tacked some posters up where you can see pictures of this kind of stuff. And from there, we will have tubes running into every room of the house, supplies to bedroom and living spaces, and exhaust from the kitchen and bathrooms. And that thing, again, runs 24/7 and brings fresh air through the building. If you wanted to recreate the effect of a machine like that in your home, you would have to open all your windows every 3 hours for about 30 minutes. And nobody in Minnesota does that, obviously. So needless to say, we have a high level of air quality once that system is in place. On the heating and cooling side, heating and cooling are reduced by about a factor of 10 over code-compliant construction. So our heat load is very, very small. In this building, we have a heat load just under 5,000 watts. For those of you who've ever checked on your hairdryer, I don't use a hairdryer for obvious reasons, but if you were to look at a hairdryer, you would find they're about 1,500 watts maybe. So we can heat the entire building here on the coldest day of the year with 3 hairdryers going simultaneously. So that will be the extent of the heating system that will find its way into this building. And it's going to come in the form of an air-to-air heat pump. Some of you may know this also as a mini split system. There's an outdoor unit and an indoor unit, and in this case, the indoor unit will be ducted. So it will resemble in some components what you know from a furnace system in your house, but it will be minuscule in size and output in comparison to what a conventional furnace is. Most furnaces might be 60 to 100,000 BTUs. We're talking about peak heat demand here of 12,000 at best. And then we also have a hot water system. Obviously, hot water still needs to be generated, and we're doing that just by virtue of an electric water heater. So that's actually very basic technology, and it'll be coupled with a wastewater heat recovery unit. And what that means is the wastewater going out of the building will be tapped for its warmth. So if you're taking a shower, for instance, which is a high demand for hot water, that water that's going down the drain will still be really warm. And so we're basically installing a piece of pipe made from copper and looping the water from the city around it. And so as the city water comes in, it's getting warmed up by the effluent leaving the building. And that means the hot water heater has a lot less work to do. It's a stupidly simple device that could be installed in any building and reduce the energy demand for hot water probably by anywhere from 30 to 60%, depending on how you're able to do it. And those things should almost be mandated in my book because they cost very little and they're extremely efficient. So it's basically the water version of what we're doing with Ventilator. And then final piece in the puzzle, when we're talking about energy, This house will also have a photovoltaic system on the roof. There will be 30 panels on the main roof facing due south. A 9.3 kW system for those of you who can work with these numbers. And that system will produce, on average, as far as we can tell right now, more energy in any given year than the building will consume below it. And it will also make this Passivhaus Plus, which is a level of certification. At the moment, there's only one Passivhaus Plus in North America, so this will be only the second building at that level of performance with those systems. So there we wrap up the energy. So I think you got sort of an overview. At this point, I'm happy to take any questions and do a deeper dive. We can do it together, but you're welcome to branch out. If you've had your fill of Passivhaus, then thank you for coming. Feel free to talk with Janneke about Passivhaus Minnesota. Talk with the Passivhaus owners about their experience with these buildings once they're built. Let me know if you have any questions architecturally, engineering-wise, and then the Reuter Walton crew and Seth Tanner about construction.